Okay, this is the last part of that exercise, the second and last. Let's see what we need to do next. Point 5, measure the distance from the middle of each part to the other surface. Okay, so this is the middle of each part, right? And so we have those points. Let's start another group. And we need the second surface. So this is the second surface, and we want to use it as a parameter in our next group. I don't want that kind of entanglement. I don't want that wire to go through another group, so I will use a relay. You can put a relay on any wire by double-clicking on that wire. So I double-click on the wire and I create a relay. This is just a kind of this is a tool to organize your scripts. That's what I can tell. So they look tidier. All right, we need to measure the distance from all of those points to another surface. Now, what is the distance? How can you define the distance? You could either, I will draw that as an example. So if you have a surface and a point, then you could either shoot a ray in some direction, so this is a vector. You could shoot a ray and check for intersections, check for an intersection with the surface, and then measure the distance between the intersection and the point. So this is one way, and this might be the most accurate way of doing that. But we want to simplify things a little. So instead, for every point that we have, we will check the closest part of the surface. There is a component for that. So Rhino can automatically find where is the nearest point on the surface, and it will give us the distance immediately. Why the first approach might be more accurate than the second one? Imagine that your surface looks like that in cross section, and you have a point here. And now, if you shoot a ray in one direction like that, then you define how you want to measure the distance actually, right? You will have something like that distance, and if you just look for the nearest point, then the chance is quite big that the nearest point would be somewhere here. And maybe the distance will not be the distance that you meant. If you would go to extremes like that, for instance, and you want to, you mean that distance as one that you are looking for, then of course shooting a ray would be more accurate. But as I said, in our case, looking just for a nearest point on the surface, so this one will be the nearest, will be enough, will be precise enough for us. So we are not shooting rays to a surface. Instead, we are using a component which will find the nearest point on a surface. So let's go back to Rhino. We have the point and we have surface. Now let's look if we maybe have some useful component here. And actually the only one that looks like it could give us any distance is pull point component. And this is what we will use. Pull point component works for points and any kind of geometry. It will for each point that you provide, it will find the closest point on the nearest geometry that you provide here and will give you the distance. So this is the second version. This is the second approach. Oops. This is that second approach from here. So it's not shooting any rays, it's just looking for the nearest point. But okay, we have the distance. Let's assume that this is the distance that we were looking for. So we have 0.5 already done. And then the last part, extrude all surfaces along vector y using the measured distance as length. Let's try it. So what components do we have left here? Extrude, scale. Okay, scale, we don't need it anymore. We have extrude and unit y. So extrusion takes two inputs, the base profile or the base surface. I suppose that we need those frames here. And the direction of extrusion. So we are in the assignment, it is clearly specified that we want vector y as an extrusion distance, extrusion direction. So I will use it. We already have some three-dimensional geometry here, but the vector here created in that component has length equal to 1, and instead we will use that distance between the surfaces as the extrusion vector. And this is what you get. So instead of having another parameter that would define the extrusion distance, we used another geometry in the file as the as a parameter, actually. So we created those boxes between two surfaces. And this is the end of the exercise, so I will just contain that in a group. So the extrusion, it's a B-rep, it's a closed B-rep, so it's a solid. Turn off the preview and put it into the final model. I will call that group create boxes. And well, that's it. You can change some of the inputs just to see how it changes. Before doing that, I suggest reducing the number of divisions because extruding and creating solids is pretty time consuming. As you have seen before, for 100 boxes, it took my computer to 400 milliseconds to calculate all that. So it already makes the script somehow unresponsive. So you need to bear that in mind, that creating B-reps is quite a heavy task for your PC. Alright, so that's all. You can bake that model if you want to see how it looks like in the rendered mode. And yeah, that's all. So thanks for watching. Hopefully you learned something new.